Lesson 3 has three parts. First part, we're going to talk about the conditional and related statements, which is going to be the first video. In the second part, part 2, we will talk about biconditional statements, which is this part. And then in part 3, we'll we'll determine the validity of an argument using standard form and also using a truth table. So feel free to go through skip videos or jump to the one that you want to watch. So let's start the first one. Part 1. So let's do a little review before we move on to the example below. So conditional statement can be in the form of if P then Q. And we use this little arrow notation over here, arrow notation for conditional statement. P statement is called the antecedent, which is the part after the if. And the Q statement is called the consequence, which is the part after the then. Now, P implies Q is really as if P then Q, which how P implies Q. Now, on the right-hand side here is the basic, very basic conditional statement for the truth table for it in standard form. And we said that conditional statement is only false if we have true followed by false. Otherwise, it's true. Okay, so now let's do number 1. First, I'm going to write it in standard form. So if we call in standard form, we said that the first half is true, the second half is alternately true and false for a table with two components, simple components. So two simple components is n equal to 2. So you will have 2 squared, which is 4 rows. That's why I have 4 rows over here on setup. So let's do it. So I must have true, true, false, false, true, false, true, false. Now I'm going to simply bring down this compound statement here into the first one here. So I have P and P implies Q and then Q. Okay. Now to make a truth table for a compound statement here, we just always look inside out. Oh, let me make it a little better, just a little, so you can see a little better. Let me do a black grouping symbol for this one so you see clear. Better. Okay. We also do inside out. Inside out, first thing we look at the very inside, which is a parenthesis, the simple components. And then look at the connectives. Once we finish the first most inner grouping symbol, then I look outside, a little bit outside. And outside we have a bracket. So we have a simple component inside a bracket. So we're gonna do this one, the P, and then I look at the connective N. Once I finish that, then I look outside the grouping symbol. Then I see the Q. And lastly, I'm gonna look at the connective for conditional, which is the right here. So let's do it. Let me copy, make it better. Okay, so I'm going to bring down the true values for PQ. Here, I suggest you pause the video and try it yourself. So P is true. Let me do this. So true, true, false, false. Q is true, false, true, false. Here, to do the column in the middle, I'm just going to have to use these 2 columns here. Okay, so this 2 column going to give me the connective in the middle. So we say true conditional is only false, but true followed by false, which is still the standard form here. So here is false. The rest of them is true. Okay. Once I've done this, I have finished this column. I'm gonna look outside. Now outside component, I see that is my P. So not for easy discussion, let me label this column 1. This one is 1. Okay. And once I finish that simple component P, so I have to bring it over, bring the value, true, true, false, false. Now I need to ask myself, which column do I need to when I make truth table for this column here? Well, this is connected for N, and well, what is this N connecting? It's connecting this compound conditional here with the simple component here. So I need the true value for this compound statement. and with this P to find this N. So which is column 1 data label. So to solve this, I need to use this one. Oh, that means maybe label this column 2. Okay, that means I need to use this one with this one to solve for this connective right in the middle here. So let me do it. So I am doing this one in the middle. So here I have true. So again, true, N is true. We said that is if both components are true. So this one's a true, false, false, false. I'm gonna make this column 3. Okay, and I'm gonna erase this arrow. Now column 3, it gives me the true value for this whole compound statement. Now, so I'm going to keep that in mind. So later I'm going to use column 3 to solve the connective here. And because this connective connecting the left compound statement with my Q. But first, before let's do the Q. The Q, it bring it over. True, false, true, false. Okay, I can make this column 4. Once I finish, now I'm going to use column 3 and column 4 to find the true value for this column over here. Okay, so let's do it. The first one is true, so therefore it's true. False, false is true. False, true is true. And false is true. Again, we call conditioner is only false if it's true followed by false, but we don't have anyone here, so all true. So that will be my column 5. Now column 5 is the true value for the given compound statement, the whole thing. So note that this is always true. Something is always true. We call it a tautology. So this is a tautology. A tautology. Okay. Now let's look at the related statement for conditional statement. Now related statement conditional, we already know for this part here. The first part is conditional. I'm gonna find the true table for conditional and contrapositive first, and in a moment you know why I picked these two to do first. So for conditional, recall it says only false if it's true followed by false. So this one is false, and the rest of them is true. Okay. Now I'm gonna do the contrapositive. And for the contrapositive, I have contrapositive conditional is not Q implies not P. Well, not Q is or the negation of Q, so therefore I'm going to negate Q. Q is true, false, so we're going to become false, true. So false, true. And here I'm going to negate P. P is true, false. I'm going to become false, true. Now, again, I'm going to look at the connective here. So the connective I have conditional is false, only true followed by false. So the only one that's false is the second one. The rest of them is true. Now, notice that what do you see? Look at conditional and contrapositive. Okay. Notice that both have the same true value. So therefore, we say conditional statement and the contrapositive are equivalent. So to represent them in notation, I say P, we write it as this way, P implies Q is equivalent to not P, Q implies not P. Now, let's look at converse and inverse. Okay. For the converse and inverse, I'm just bring the values over. True, false, P is true, false. And here, fill the true value, only, again, conditional, is false if you're true followed by false. So this one is false. True, true, true. Now let's look at the inverse. The inverse is a negation of P implies negation of Q. So let me do negation of P first. So false, false, true, true. Negation of Q will be false, true, false, true. Now I'm gonna look at the connective, and so this one is true, true, false, and true. And notice that this column is the same. These two columns here. Again, so therefore I say that the converse and the inverse are equivalent. And this column earlier we said is the same. So this is same. And in notation it's equivalent. So let me write the equivalent statement for the converse and inverse. So we say converse is Q implies P is equivalent to not P, or negation of P implies negation of Q. Okay. Let me zoom in a little so you could see the whole picture here. Now let's look at below. Determine a given statement are equivalent. I noticed quite a few you missed this question in your classwork. So this one here, to determine whether something is equivalent or not, we say we want to see if they have the same true value. Or we can say if it's one is a conditional, the contrapositive of the other, or maybe it's the inverse or in converse. So let's see. So one way to do it is by truth table. Another way is to recognize whether one is contrapositive to the conditional, or if it's converse and inverse. So let's write it. Before I do that, I will need to write that in symbolic form first. So in symbolic form, this one is, we say if a number ends with 5, then the number is divisible by 5. So let's make some notation. I'm gonna let, we don't have to use PQ all the time. We can use some other letter. And let's use N for a number that is ends. Let's use E this time. It's just for fun. Let's use E. Let's use E to stand for a number ends with 5. A number ends with 5. So a number ends with 5. Then I'm gonna use the number is divisible by 5. I'm gonna use D for represent a number that is divisible by 5. So a number is divisible by 5. Now I'm going to translate statement 1 and statement 2 in symbolic form, symbolic notation. So statement 1, symbolic form. And first statement, this is the first statement. The first statement says, if a number ends with 5, notice there's an if there, so it's a conditional statement, and then this is conditional statement. So we're going to have an if and then. Tells me I'm going to have conditional statement. Well, a number ends with 5 is E. We use E for notate that, so this is E. A number divisible by 5, we use D for denote that, so this is D. So E implies D. That is the first statement. Okay. Let's look at the second statement. The second statement I have if a number divisible by 5. Well, number divisible by 5 is D. Then the number ends with 5. Again, this is a conditional statement. I have if divisible by 5 is D, so D implies ends with 5, which is implies E. So let me write it. So I have D number divisible by 5 implies a number ends with 5, which is E. Now let's look at the relationship of the first statement and second statement. So first statement is E implies D. The second statement is D implies E. Well, let's look at our table over here again. So E implies D is the conditional form, and in the second one, I basically flip them. So does it look like just the converse? P implies Q, Q implies P. So E implies D, D implies E. So the second statement is the converse of the first one. Second statement is the converse of the first statement. Now that, well, do we say the conditional statement and the converse are equivalent? No. Notice that we said the conditional statement is equivalent to the contrapositive. So therefore, these statements are not equivalent. The given statements are not equivalent. Okay. And this completes our lesson 3 part 1. Let me zoom in a little so you see the whole thing here. And thank you for watching. In the next video, we're going to do part 2 by conditional statement.